What's up guys, this is Waleed and today's problem is the ice and water. So a single 50 grams ice cube is dropped into a thermally insulated container holding 20 grams of water. The water is initially at 25 Celsius and the ice initially at minus 15 Celsius. So the first question, what's the final temperature of the system after it has come to thermal equilibrium? So what we're going to do is the mass of the ice times the specific heat of the ice, delta T, plus latent heat fusion of the ice times the mass of the ice plus mass of the ice, specific heat of the water, delta T equal mass of the water, C of the water, delta T. Okay? This sickness is killing me. It's been 2 days since this flu. Anyway. So mass of the ice is 0.05 in kilograms and then 2200. Delta T, we're looking from minus 15 to 0. So the difference is 15 plus 400 times the mass of the ice, which is 0.05 plus mass of the ice 0.05 times 4186 times delta T. Delta T is going to be going from T final minus 273. Okay, this is going from 0 Celsius to whatever T final is. And then this guy, hope it fits. Let me zoom in. It's 0.2 times 4186 times 29.8 minus T final. Alright guys, so now we're just solving for T final. So T final in this case was 275.49 Kelvin. They want in Celsius, so T final in Celsius is going to be 2.49 Celsius. Okay. So in terms of mass, how much of the ice has melted? The total, 50 grams. Because the whole ice, we used the latent fusion and the whole ice turned and then some of the ice went up in temperature. Okay. So in number 3, let's drop a second 50 grams of cube ice into the system. What's the final temperature of the system after it has come to thermal equilibrium for the second time? So now we know that we have, as in water, we have 0.25 kilograms of water at 2.49 Celsius. Okay. And then we added 0.05 kilogram of ice at negative 15. So now let me take this to the bottom right here because I'm going to need more space. So how much energy would it take to turn the whole water to just 0 degrees? So let's do the math. So 0.25 kilograms times 4186 times the 2.49, which is minus 0. So this is equal to 2616.25 joules. That's how much water from 2.49 to 0. Okay. Now ice from negative 15 to 0, it's 0.05 2200, and then times the temperature, and difference in temperature is 15. So this guy was equal to 1650 joules. Okay, so now we can see clearly that the ice is going to actually melt to get the water to 0 degrees. So it's going to melt from it. So you're going to use latent heat diffusion. So it's either the water is going to go to ice or the ice is going to go to water. But since the difference is the water is going to require more energy to get to 0 degrees, that means the ice is going to have to melt. Now the water is going to turn to ice. Okay. If the ice energy, if this guy was bigger, then the water would turn to ice. Some of the water would turn to ice. Okay. So the final temperature, as you guys can see, is equal to 0 Celsius. TC final 0 Celsius. So here's 0 Celsius. Okay. So what's the total mass of ice, including the first cube, melted during this entire process? So we're going to do 50 times whatever melted in this process in here. So the difference in between those guys is what's going to turn the ice into water. So 2616.25 minus 1650 divided by the latent heat of fusion, so 333,400, and this one will equal to how much was that guy? 0.0289 grams. Okay. No, not grams, kilograms, and then so change it to grams, which is 2.89, and then so you add this guy to here, 2.89, so the total is 52.89 grams. Alright guys, hope this makes sense and helps. Good luck. Bye.